my dear students. My name is 𝗧𝗦𝗃 and I am a senior chemistry faculty. So, today we are going to discuss about the previous year NEET question paper with solutions, because these are very important at the end of the your academic year. Before writing examination, it is very important to solve the previous year question papers. So, now I am here to explain you previous year question paper. This is 2023 question paper. I am going to solve the previous year question paper 2023. You just follow it and try to understand the concept and don't try to understand the solution, how I am doing. You just try to understand the concept involved in it, formula involved in it, and try to absorb that formula. Okay. So, the very first question, this question is from periodic table, that is zirconium and hafnium have similar atomic and ionic radius, and what is the reason of it, he is asking. So, option 1 is having similar chemical properties, option 2 is belonging to the same group, and option 3 is diagonal relationship, option 4 is lanthanide contraction. See, if you can see zirconium and hafnium. Zirconium is a 4D series element, hafnium is a 5D series element. So, while coming from top to bottom, atomic radius should increase, right? But 3D to 4D, 3D series to 4D series, atomic radius will increase, a regular pattern. But 4D to 5D, atomic radius will remain same, atomic radius remains same. Atomic radius as well as ionic radius, both will remain same. Why? Means due to lanthanide contraction. Lanthanide contraction. I think you have already studied lanthanide contraction in periodic table. What is lanthanide contraction? Because of the poor shielding effect of 𝗪𝗏𝗏, what will happen? The size of the atoms will decrease, lanthanides will decrease. Due to poor shielding effect of 𝗪𝗏𝗏, the size of the lanthanides will decrease, that is lanthanide contraction. Similarly, we have actinide contraction also. But here 3D to 4D lanthanide contraction will be there, 4D to 5D lanthanide contraction will be there. Because of their size will be small decrease is nothing but remaining same, right. So, the correct option is lanthanide contraction, option 4 is the correct option. Got it? So, this question is 2023 and this question is particularly from which chapter? Periodic table chapter. And particularly they have asked about D block elements. This is about D block elements, right. And coming to the, if you can take the atomic radius of zirconium, it will be around 160 picometers and this will be 159.5 picometers, almost same because of lanthanide contraction. Okay. So, next question, which one among the following is the correct option for right relation between Cp and Cv? This is not Cy, this is Cv for 1 mole of an ideal gas. So, what is the relation between Cp and Cv he is asking. Okay. See carefully, we know that at a constant volume, heat capacity will be QV is equals to Cv delta T. At a constant volume, heat supplied QV is equals to Cv delta T, and at constant pressure Qp is equals to what? Cp delta T. And we know one more relation also, delta H is equals to delta E plus delta nRT, that is N is 1 mole. N is 1 mole means 1 into RT will be RT. So, QV is equals Cv delta T, this is nothing but at constant volume heat capacity is equals to change in internal energy. At a constant pressure, heat capacity is equals to change in enthalpy, right. So, delta H is equals to delta E plus delta nRT, delta N value is 1, that is why we have kept delta RT, right. So, this we can write it as delta H is equals to delta E plus R delta T, right. So, delta H we know, delta H is what? C P delta T is equals to C V delta T plus R delta T. If you take delta T common, this one will be C P is equals to C V plus R. You can write C P minus C V is equals to, so C P minus C V is equals to R. Option 3 is correct. This particular topic is from which chapter? It is from thermodynamics chapter, very important, heat capacity thermodynamics. This is also 2023 question. So, the correct relation between Cp minus Cv is equals to R. Cp is what? Cp is heat capacity at constant pressure. Heat capacity at a constant pressure. Cv is equals to heat capacity at a constant volume. Okay. And sometimes you will be given in a different mathematical expression, like you may be asked Cp is equals to Cv plus R. This is also correct. Cp minus Cv is equals to R, Cp plus Cv is all, Cp is equals Cv plus R is also correct. You should not get confused, right. You should not get confused whether it is Cp is equals to Cv plus R or Cp is minus Cv is equals to R. Both are same. రెండు కూడా ఒకటే. Cp is equals to Cv plus R అన్న, Cp minus Cv is equals to R అన్న ఒకటి. This we have derived from where? QV, heat capacity at constant volume, heat capacity at constant pressure. Okay. Thermodynamics is also very important chapter. I have mentioned some important topics in the live session. Mainly first law of thermodynamics, heat capacities and terminology. Okay. And next coming to the third question, the structure of beryllium chloride in solid state as well as in vapor state. This is very important. Beryllium chloride, BeCl2, beryllium chloride. Beryllium chloride in solid state exists in a different form, and in vapor state it will exist in a different form. In solid state, how it will be existing? It exists as a polymer. In solid state, it exists as a polymer. It means it will be like this, BeCl, Cl, and you will be having another Be here, it will be Cl, Cl, here also Cl, Cl. So, there is a bond between these two, and another Be like this, Cl, Cl. So, like this, between two BeCl2 molecules a bond is formed, right. So, it exists as a polymer like this, it will continue, here chlorine, here chlorine, here chlorine and here chlorine, it will continue. But in vapor phase it exists as only dimer. In vapor phase it will be existing only as a dimer like this, BeCl, Cl, beryllium, and Cl here, Cl here. Each beryllium 2 chlorines only. It is a dimer. This is one BeCl2, and here this is another BeCl2. Got it? So, BeCl2 in vapor phase is dimer, and BeCl2 in solid phase is what is this? Polymer. This particular question is from S block elements. Actually, S block elements this time you do not have. This is actually 2023 question paper, that is why this particular question is there. But anyhow, it is very, I mean, it will be very useful if you can understand this or remember it. Okay. And next, coming to the fourth question. This is tritium is a radioactive isotope of hydrogen, emits which of the following particle? This question is from hydrogen and its compounds. I am writing the chapter name also. and this question appear in the NEET 2023. NEET 2023 లో వచ్చింది క్వశ్చన్. సో ఇక్కడ isotopes. How many isotopes you have for hydrogen? 3 isotopes. H11, which we call it as protium. H12 is called as deuterium. H13 is tritium. H12 deuterium. H13 is tritium, which also can be represented as T. Tritium is a radioactive element. Radioactive element. Radioactive element. Tritium is a radioactive element which emits a beta particle. Tritium emits what particle? Beta particle. Beta particle is a low energetic particle. Remember, beta particle is a low energetic particle. Tritium is a radioactive element which emits a beta particle which is a low energetic particle. So option 2 is correct for this question. So how many isotopes you have for hydrogen? 3 isotopes. The radioactive isotope of hydrogen is tritium, and as it is a radioactive isotope, so which particle it will emit? ఏ పార్టికల్ ఎమిట్ చేస్తుంది అంటే బీటా పార్టికల్ ఎమిట్ చేస్తుంది. ఓకే, అండ్ నెక్స్ట్ క్వశ్చన్. The major product formed in the dehydrohalogenation reaction of 2-bromopentane is pent-2-ene. This product is formed based on which of the following rule? One is Huckel's rule, option 2 is Sergeff rule, option 3 is Dock's rule, option 4 is Hoffman rule. So this question is based on organic chemistry, second year. This question is particularly, we will study about this question is in alkyl halides. Alkyl halide. This time you may get 2 or 3 questions from alkyl halides, very, very important, because we have many chapters deleted, right? That's why this time we will be getting more than 1 question from the alkyl halides. See now, what he is asking is the major product formed in the dehydrohalogenation reaction of 2-bromopentane. What he is telling is 2-bromopentane. 2-bromopentane dehydrohalogenation, right? Dehydrohalogenation, elimination. Elimination means what is the reagent you have to use? Alcoholic KOH, right? Just ఏమొచ్చింది? pent-2-ene వచ్చింది. See carefully, 2-bromopentane means how we will be writing CCC 1 2 3 4 5, right? Here CH3. First carbon, second carbon, bromine will be there. Here we will write CH3, CH, CH2, CH. This is 2-bromopentane. If you will be giving alcoholic KOH, what will happen? This come here. Here you will be getting plus charge, right? Br minus will be leaving group, so that you will be getting CH plus, right? See, I am writing here CH3, CH2, CH2, CH plus, CH3. So these 2 are alpha carbons. From alpha carbon, hydrogen is eliminated. See, for example, here 1 hydrogen is there. Here 1 hydrogen is there, 2 hydrogens, and CH3 means here 3 hydrogens, 1, 1, 2 and 3, 3 hydrogens. So if hydrogen is eliminated from, I am writing this first one, this is second one, eliminated from first carbon. So what is the product you are going to get? CH3, CH2 and CH double bond CH, CH3. If hydrogen is eliminated from second one, what is the compound you are going to get? CH3, CH2, CH2, CH double bond CH2. The first compound is 2-pentane, pent-2-ene, what he tells is. Second compound is pent-1-ene, okay. So, this is 𝗧𝗃 rule. According to 𝗧𝗃 rule, more stable product is the more substituted product is the more stable. Here this one is more substituted, here more number of alpha hydrogens. In the first compound you have 5 alpha hydrogens, and in the second compound you have only 2 alpha hydrogens. More number of alpha hydrogen is more stable. More stable product is formed according to the 𝗧𝗃 rule. More substituted product is more stable product. Okay. So, this question is from alkyl halide. Alkyl halides is this time is very important. You may get 2 to 3 questions. So, next question, electron deficient molecule. BF3 is a planar molecule and electron deficient compound. Hybridization is asking hybridization, number of electrons around the central atom respect. So, this is group 13 elements question, BF3. How can you find out the hybridization? If you can write its structure, fluorine, fluorine, fluorine. So, number of valence electrons plus monovalent atoms by 2. Hybridization. How can you calculate hybridization formula? I am writing here, very important, all of you can know it. Enter the formula, number of valence electrons plus number of monovalent atoms, plus or minus charge. If you have positive charge on the molecule, you have to write plus charge. How much positive charge is there? Plus positive charge. If you have negative charge, minus negative charge by 2. So, valence electrons for boron is 3, and one second, there is small mistake. Valence electrons for boron is how many? 3. Valence electrons for boron is 3 plus monovalent atoms like fluorine. How many are there? 3. Charge is not there, that is why charge 0 by 2. So, 6 by 2 is 3. If you are getting 3, you will be having S1 P2, 2 plus 1 3, sp2 hybridization. What hybridization? sp2. With sp2 hybridization you have 2 options, one is first one option, second one is fourth. How many electrons present around the boron? See, boron is having 7 electrons, 1, 2, sorry not 7, 6 electrons, 1, 2, 3, 4, 5. So, sp2 hybridization 6 electron, and it is a electron deficient compound. Electron deficient compound because it do not have octet configuration. Octet configuration means any molecule in their compound should have 8 electrons, right. That is why it is a electron deficient. So, BF3 and anything is undergoing sp2 hybridization, it will be having trigonal planar shape. Remember carefully, trigonal planar. sp3 means tetrahedron, right. And next coming to the, what is the IUPAC name of the organic compound formed in the following chemical reaction? So, what will be the chemical reaction? Acetone. How can you write acetone? CH3, C double bond O, CH3. And what is there over there? See carefully, C2H5 MgBr, dry ether. This is a Grignard reagent. C2H5 MgBr dry ether is a Grignard. C2H5 MgBr. So, how can you break the Grignard reagent? Tell me. How can you break the Grignard reagent? It will be C2H5 minus Mg plus 2 Br minus. So, the bond between carbon and oxygen shift towards oxygen side, right. As a result of which, what you are going to get? You are going to get is CH3, CO minus, C plus, right, and CH3. Now, see, on O minus what will be added? Mg plus will be added, Mg plus 2 Br minus will be added. And on C plus what will be added? C2H5 minus will be added. As a result of which, what you are going to get is CH3 CO MgBr plus, here CH3 is there, and here C2H5 will be there. This is, he reacted with second reagent is what? H2O. In H2O, what you are going to get? H plus and OH minus. So this H plus attacks on O minus and OH minus will come with MgBr. So that you are going to get is CH3COH and here C2H5 and here CH3. Okay. So what is the correct option over there? This is 1, 2, 3, 4 butanol. What butanol this is? 1, 2. 2 methyl is there, alcohol is there. 2 methyl butane 2-ol is the correct answer. 2 methyl butane 2-ol is the correct answer. Acetone Grignard reagent. Acetone is a ketone. Ketone when reacts with Grignard reagent followed by water will give the tertiary alcohol. Otherwise, aldehyde Grignard reagent and water will give the primary alcohol. Sorry, not primary, secondary alcohol. Aldehyde Grignard reagent followed by hydrolysis will give secondary alcohol. Ketone Grignard reagent followed by hydrolysis will give the tertiary alcohol. Okay. And next, coming to the 8th question. The molar conductance of NaCl, HCl and CH3COONa at infinite dilutions are given 126.45, 426.16, 91.0 Siemens centimeter square mole inverse respectively, the molar conductance of CH3COOH at infinite dilution. So what you have information? You have information of CH3COONa, right? Its molar conductance is given. And we have information of hydrogen chloride molar conductance. If you react these two things, what you are going to get? CH3COO minus and H plus will combine and forms CH3COO minus H plus, CH3COOH, acetic acid. And Na plus and Cl minus will in turn react and forms NaCl. What he is asking is, he is asking the molar conductance of CH3COOH. If you want to get the molar conductance of CH3COOH, what you have to do? You have to add the molar conductance of CH3COONa and H and subtract NaCl. You have given the molar conductivity of sodium acetate, hydrochloric acid, NaCl. Add the molar conductances of sodium acetate, hydrochloric acid and subtract it from NaCl. So that you are getting CH3COOH, right? So the molar conductance of CH3COOH, molar conductance of CH3COOH is equals to molar conductance of CH3COONa plus molar conductance of HCl minus molar conductance of NaCl. Tell me, molar conductance of CH3COONa will be last one, right? 91 plus and HCl is 426.16 minus 126. NaCl is 126.45. So that you will be getting answer after calculating all these things 390.71 conductance Siemens centimeter square mole inverse. So the correct answer for this one is option. And next is 9th question. The incorrect statement among the following is: actinides are highly reactive metals, especially when finely divided. Is it correct or not? It is also belongs to D and F block elements. See, in 2023, D and F block elements we got 2 questions. So actinides are highly reactive metals, especially when finely divided. Correct or not? Yes. If it is finely divided, what will happen? Surface area of the elements will increase. If surface area increases, reactivity is what? High. That is the correct statement. He is asking us to find out incorrect statement. Okay. So second option, see, first option is correct. And second option, actinide contraction is greater for element 2 element than lanthanide contraction. Yes, actinide contraction is higher because shielding effect is very poor in 4f orbitals or 5f orbitals, sorry, 5f orbitals. Okay. Shielding effect is very less. That's why. So this is also correct. And most of the trivalent lanthanides are colorless in the solid states. They are not colorless in the solid state. Most of the trivalent lanthanides are colored compounds. So this is the incorrect statement. This is the incorrect statement. So this is your answer. Okay, I am taking right, but this is your answer. But the other 3 statements are correct statements only. He is asking incorrect statement. And lanthanides are good conductors of heat and electricity. Yes, they conduct heat and electricity because they have mobile electrons. If electrons are moving, free electrons are there, it will be conducting heat and electricity. Next, see 10th question. Acidic strength in the order of given as HF, HCl, HBr, HI. He is telling that what HF is least acidic. HF is least acidic and HI is most acidic. Is it correct or not? Yes, it is correct, because HF the bond length is very less, but HI the bond length is very high. Bond length is very high, HI can be broken down very easily and loses H plus ion very easily. And something is losing H plus ion very easily, it is more acidic, right? Yeah. So that is what he is saying. As the size of the element from fluorine, chlorine, bromine, iodine increases down the group, the bond strength will decrease. Yes, bond strength is decreasing. So the H plus ion donation is very easy, and hence it acts as a very good acid. It acts as a very good acid, right? That is why both statement 1 and statement 2 are true. Both statement 1 and statement 2 are both are true. Okay. And next 11th question, the correct structure of 2,6 dimethyl dec4-ene. 2,6 dimethyl dec4-ene is 2. See, if you can give numbering here, we will give numbering like this. I will be writing like with red pen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 carbons. So dec. 4-ene. 4th place lo double bond ene. 2 methyl is there, and at 6 also methyl is there. 2,6 dimethyl. Right. And next, coming to the last question, the correct sequence of bond enthalpy of CX bond. So here we have is comparing CH3F, CH3F and CH3I. As we are moving from top to bottom, the halogen atom size will be increasing, right? We can see CH3Cl like this, and one more is CH3Br. So bond length is increasing, right? Here bond length is less, here bond length is somewhat more. So this is the order of bond length. Bond length is less than like this. This is the order of bond length. But bond enthalpy opposite. Bond energy. The correct sequence of bond energy. Bond energy is what? CH3F is having more bond energy than CH3Cl, than CH3Br, than CH3I. So what is the correct answer is the third option. CH3F is having more bond energy, less bond enthalpy. So in this session I have explained 12 questions, and in the next session I will be explaining 12 more questions. So practice previous year question papers thoroughly. Not only this many questions, you have to practice many number of questions. These are just some examples of previous year questions. You have to practice many questions to score good marks. Okay. Thank you very much.